a little smarter about what it is we're seeing when we see satellite imagery. And satellite imagery, of course, just to throw back to a term we learned at Good Grief the very, very first day of the course, is an example of remote sensing. I mean, the satellite doesn't swoop down into the clouds to go find out how high they are or how cold they are. It does it from a distance. In fact, probably from a pretty darn good distance. Let's see if this will work. There we go. Broadly speaking, there are two types of satellites out there. There are what we call the geostationary satellites, and there are the polar orbiting satellites. This is not just a meteorology thing. This is in general how satellites work. So, okay, let's be clear about this here. The satellite is the whole big piece of equipment that probably has all kinds of antennas and sensors and cameras on board. Okay. We'll talk about the different kinds of cameras it can have on board or the different kinds of sensors in just a little bit. We're just talking about the platform itself. Okay? The platform itself can either be in geostationary orbit or it can be in polar orbit. Geostationary, if you parse that word geostationary, Earth ain't moving. Geostationary satellites are in an orbit that doesn't look like it moves. If you are on a geostationary satellite, you're in a very specific place. You have to be directly above the equator, and you have to be exactly 36,000 kilometers up. But the nifty thing about being exactly above the equator, 36,000 kilometers up, is that you will be moving at a rate that you orbit the Earth once every 24 hours. But of course, in that same 24 hours, the Earth will have turned around once. So from your point of view, it's like the Earth isn't moving, right? If you are in that satellite, and there's nobody on board satellites, right? They're not that big. But if you were on board it would seem to you like you were just staying above the same spot. But you're not really staying above the same spot. I mean, you're going around the Earth every 24 hours, but the Earth turns every 24 hours. You just stay right about that same spot. That's a mighty handy thing. Think, for example, about satellite television. If you have Dish Network or something silly like what's the right word? I can't think of the right word. If you have something like that, it's useful that you can take your dish and you can point it towards the sky, and the satellite's there. He's pointing towards the satellite, right? The satellite's in fact moving. It's going around the world every 24 hours, but so are you. I mean, so when the dish is pointing that way and the satellite's there, it's going to stay there. That's a handy thing. It would be very complex if your satellite dish had to be on some kind of rotors, and servos that kept it pointing towards where the satellite was. Right? That would be very, very complicated. Hey, have you ever noticed, by the way, that satellite dishes too always point south? That's because from our point of view, from where we are, if they're over the equator, they're south of us. Right? You never see satellites pointing north. Satellite dishes that one. This is awfully handy. This is a very, very useful place to put a satellite because it doesn't seem to move. And so if you have a satellite, a meteorological satellite parked someplace, let's say right above Central South America, when you look this way, you're seeing Nebraska. When you look this way, you're seeing West Africa. When you look this way, you're seeing Argentina, and it doesn't change. You always know what the satellite is seeing when it points its camera that way. That's a useful thing. In fact, in meteorology, we have, well, two such satellites. Okay? One is parked more or less over Hawaii, roughly, and one's parked more or less over Central America, South America. We used to have a third one, but that one's not working anymore. So we have two. How many satellites do we have out there that transmit direct TV? Lots. Okay, you can see where meteorology stands. It's a great scheme of things. This is all in contrast to the polar orbiting satellites. I should have brought a globe today, but I had so much other stuff to bring. So we're going to pretend that this box is a globe. There are nice examples, by the way, on that silly Dave Matthews video, animations of how these satellites work. The kids found some students found some clips of video online that they stole. And so, polar orbiting satellites fly in an orbit that goes over the North Pole, then down, and under the South Pole like this. And they just keep going around and around like this, and the Earth rotates underneath them. So they get to see lots of different places over the course of a day. Right? The Earth just keeps rotating underneath them. Oh, look, India. Oh, look, West Africa. Oh, look, the Caribbean. As they just keep, they just keep flying around and around, and the Earth rotates underneath them. And they are in a very low orbit, maybe like 300 kilometers up, compared to the 36,000 kilometers up that geostationary satellites are in. This is very, very close. It's also a very fast orbit. It only takes them about an hour to get around the world. Okay, so I mean, they're clipping. There are quite a few such meteorological satellites out there, but they're almost never used for like operational meteorology. The satellite pictures that you see on TV are pretty much always geostationary. And the reason is because it is really, really complicated to keep track of where that satellite is and what it's looking at. Okay? I mean, wherever it is now, these satellites are moving at about 18,000 miles per hour. Okay? If you want to see Omaha, you better look quick because poof, we're already over at South Dakota. You know what I'm saying? I mean, it's keeping track of where that satellite is and where it's looking is just really complicated. What tends to happen is we use these for research purposes. Like if we need really detailed pictures of some particular location, we wait till the satellite's there, or we go back and we dig through the archives and we find examples where the satellite was where we needed it to be. So we have lots of these kind of satellites. This is, for example, by the way, how the whole GPS system works. The GPS system is made of a constellation of, like, I don't know, what is there, about 20 satellites? 36. What? 36. 36, is that what it is? All in polar orbits. And by where they are at any given time, okay, if you know satellite 18 is going that way and he's moving that fast, and you know that satellite 12 is crossing over you this way, you can figure out right now where you must be. That's something, I mean, they use these polar orbiting satellites. But in practice, they're very hard to use for operational meteorology just because they're never where you need them to be. Spy satellites are polar orbiting satellites. Okay, when Jack Bauer tasks a satellite to go monitor some terrorists on 24, that's a bunch of crap. Okay, the satellite's up there moving 18,000 miles an hour. You just got to wait for when it comes over Los Angeles. And guess what? Him sitting there watching them as they get out of their terrorist ban or whatever. No, the satellite's already over Oregon. Okay, and you don't blink because it's going to be over British Columbia in a few minutes. I mean, it's just crap. 24 is crap. Anyway. On the other hand, the reason why spy satellites are in those orbits is because they're so low. As you can probably imagine, you can make a much sharper picture if you're only 300 kilometers above the ground than if you're 36,000 kilometers from the ground, right? Correct word to use here is resolution. Okay? The pictures that come from the polar orbiting satellites are very high resolution. They're just not that high above the clouds. Well, they're still 300 kilometers, but comparatively speaking, they're much closer. So satellite pictures that come from geostationary orbit are easier to work with, but they're not very high resolution. I mean, let's face it, put a camera in space, 36,000 kilometers away, you get what you get, right? It's not going to be so easy to keep this thing, to get great pictures from it. Okay, for reasons older than I am, in the United States we call our geostationary meteorological satellites GOES. It stood for something at one time, the Geostationary Orbiting Environmental System or something. We have two. Right now we call them GOES East and GOES West. And GOES East is parked right above South America. So if you just have the camera and you point it, I mean, it does this all automatically. It isn't like someone sits there and aims the camera. Okay, it does it automatically. This is its true view. If you were a satellite sitting on board the satellite, if you were an astronaut sitting on board the satellite, this is what you'd see. You can kind of see parts of Europe, but not too much. They're kind of over the edge of the globe a little bit. You can see the Atlantic good. Hey, if there's a hurricane out there, you're in good shape. You can see North America, and you can see I cut off South America because I'm not interested in that market. The true view from GOES West, it's like parked out kind of near Hawaii. It can see the Pacific, any big storms that are headed out towards North America. Hey, we're golden. We can see all of the United States. And those are it. That's what we got. Okay? All the other ones are broken. It's really hard to send this astronaut up to 36,000 kilometers up to fix the things, right? We don't fix them. They break, they break. But when you watch TV and they show you a satellite picture, they don't show you a satellite picture that looks like this. They always show it like centered on Omaha. Right? This morning I'm watching the local news and John Campbell on Channel 7 is showing me satellite pictures and they're like, it's like the satellites in Omaha stationary orbit. Okay? No, there's no such thing. That's all fake. Fake, fake, fake. Okay? There are complicated image software packages that work something like Photoshop, just because people have some idea what Photoshop does, that can go ahead and they can disassemble the image and put it back together as if we're looking at it, in this case, from like above New Orleans. But this picture was probably taken from out over the Pacific too. It's just that we use digital tricks to make it look like it's coming from above New Orleans. And we can do the same thing for any place in the United States, and we do it all the time. Real satellite pictures too are always in black and white.